we are Team LCL. Now we will show you our approach to solve the assignment 2, Pacman Capture the Flag. In this project, our task is to write an algorithm to drive the agent do two things: protect our food from being eaten and eating the opponent's food. Our team used two AI techniques to solve this problem: heuristic search algorithms and reinforcement learning. In the heuristic search algorithms, we choose the A-star algorithm. There are three modes in this approach: the defensive mode, the offensive mode, and the agent will switch its role dynamically. In the offensive mode, the agent would choose the closest food as a goal and went back home to gain the marks. It would also go back when it was chased by the opponent's agent and is far away from the closest capsule. If the offensive agent was eaten accidentally by the opponent's defender, the defensive agent would become the offensive agent and cross the middle line to gain the closest food. The reverse agent would play the defensive role. In the defensive mode, the agent would patrol on the middle line. When the food was eaten by the invader, it would go to that position. When it sees the invader, the defender would start to chase it. There are also other options for this mode. As an offensive agent, when it saw a scared opponent agent, it would do nothing but keep on eat the closest foods. As a defensive agent, when it was scared, it would cross the middle line and become an attacker. The pros of the A-star search is to find the shortest way to the goal position, such as the nearest food or the middle line. The cons of the A-star search is that it still needs to define the goal manually, and the best solution may be not the best way to pick wisely.
The second technique we use is reinforcement learning. We have offensive agent and defensive agent. Each of them has 12 handcrafted features plus one bias term. For example, the defender has features like the shortest distance to the Pac-Man, eating Pac-Man if not scared. The attacker has features like distance to the closest food, the shortest distance to ghost, and so on. Those features approximate the environment and become the agent's observation after doing an action. Later, an agent will receive a reward from that action and update the weight vector for that action. Design reward function is also an important part in reinforcement learning. A good reward function can help boost the training process. In our design, different rewards are given to different agents. For example, the offensive agent will receive rewards of 5 when it is a food. It also gains more rewards when returning the food and got negative rewards for being killed by a ghost. A defensive agent gains 20 rewards for eating a Pac-Man, but when a Pac-Man eats food, it will receive -1. There are also some rewards not showing in the slide, but they are important as well. So the advantage of approximate Q-learning is that it does not require a large space to store Q value. And it's also a model-free Markov's decision process so that we don't have to give a specific rule to an agent. The drawback of this method is that it needs a lot of time to train, and it's hard to tune the hyperparameters such as learning rate and discount factor. The challenges we face during implementation is that for A-star search, when doing role switch, we need to consider lots of situations, and when the agent starts wandering between 2 points, it's hard to break it and tell the agent to change target. For approximate Q-learning, it's hard to design features and rewards, and it's also hard to tune learning rate, epsilon, and discount factor. For A-star search, its future improvements include break the deadlock, avoid the agent from wandering around 2 positions, and make smarter decisions about choose the escape path. and also to enable the agent eat food while chased by the opponent. For approximate Q-learning, we could add more scientific features and rescale rewards so that we can train it faster. Let's now watch the demos for A-star search. Let's now watch the demos for approximate Q-learning. Thank you for your listening.